Equipment engineering told me that the system I have been modeling also has in situ inspection. Is there a way to add this data to TooCool?
TooCool incorporates inputs and outputs for direct modeling of standalone and in situ metrology systems. Let's do a quick review of why inspection and metrology systems are different than equipment used solely to process material in a manufacturing flow. The main difference is that you buy inspection and metrology equipment for what it tells you about the product, not what it does to the product. And what it tells you can either be right or wrong. In statistics, being wrong falls into two types of errors, type 1 or alpha error and type 2 or beta error. Alpha errors are when the inspection or metrology system tells you the product is defective when, in fact, it is good. Beta error is the opposite. It is when the product is defective, but the measurement says it is good. The cost of alpha errors is normally the accumulated manufacturing cost up to the point in the process where the product is assumed to be defective and is scrapped. Beta error costs can be more difficult to determine depending on where they occur in the manufacturing flow. Early in the flow, the cost is the increase in cost from where the beta error was incurred until the next metrology or inspection step that catches the error. However, if the beta error is at a final inspection step prior to shipping product to the customer, the cost can be quite significant. What are the costs associated with shipping bad product? At a minimum, it is the cost to recover the defective part and ship a new one. Depending on the nature of the part and the frequency of beta errors, you might lose the customer's business. One extreme example of beta error was the original mirror on the Hubble Space Telescope. An error in the laser measurements caused the mirror to be misformed. Think about the cost of the service call to fix that mirror once it was in orbit. This is why companies develop strategies regarding what are acceptable risks based on where the inspection or metrology is in the flow. Early in the flow, you might be more willing to accept more beta error, knowing you will likely catch it at a future step. But as you get towards the end of the process, beta error may increase your business risk, and you would be more willing to accept increases in alpha error in order to lower beta error. Let's go ahead and open your model. To enter this mode, choose the Input Metrology Input menu command. Once Metrology Input has been selected, you will be presented with an input screen of metrology parameters. To make this data active, click the Use Alpha and Beta Loss Factors checkbox. The screen asks for information on alpha and beta error rates, their respective costs per occurrence, and the sampling rate. We have the data from your equipment engineering group that says alpha error is 0.1% and beta error is 0.2%. And the costs are respectively 50 cents and $1. Since the error rates are considered to be low, the sampling plan is 10%. Choose the Undo button to abort all entries. Clicking the Update button moves the data to the main model results. Let's see how these changes have impacted the cost of ownership. The cost of ownership has increased by less than half a cent. Setting the sampling rate to less than 100% added a new line to the report called Per Good Unit Equivalent Supported under the Total Costs category. This result takes into account the sampling rate to prorate the cost of ownership value over the total number of units produced versus those inspected. This value is only useful for standalone metrology systems. By using these advanced features of TooCool, manufacturing organizations can make more efficient decisions regarding their inspection and metrology strategies. Optimization of these factors can reduce inspection and metrology costs while supporting a zero defects quality goal.